Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.5, the U-sub method. Number 1, the U-sub method. Let's begin with this example. Integral root x dx. We know how to perform this integration because that is the integral of x1 over 2 dx. But what about integral root of 2x minus 1 dx? Well, there is nothing in the integral table that tells us how to do this one. If somehow we can turn it into an integral that is similar to root x dx, then we can do it. And the way to do this is somehow we got to rewrite the 2x minus 1 here as u. So that is, we're gonna let u equal to 2x minus 1. Take the derivative of both sides with respect to x, then we have a du equal to dx. And we say that dx is half of du. So we can replace this or rewrite the entire integrand. The integrand is this part here as integral of root u times 1 over 2 du. And ta-da! We know how to evaluate this integral. This is the magic of the u substitution. When we rewrite the integrand in terms of u du, that is when we perform the u substitution. Let's take a look at another example. We know how to do the integral of ex dx. But what about integral of e 2x dx? Or e to x squared times x dx. Now, so in this example, we would like to rewrite the integral in terms of u du so that it becomes something like integral of e to the x dx. Very similar, just change x into u and we'll be able to do it. So we want e to the power u, meaning that we have to let u to be 2x squared and du here derivative with respect to x for x dx. So this tells us that x dx is 1/4 du. And we can rewrite the integral here as e to x squared times x dx. Now we can do the u sub. And we get integral e u times x dx is 1/4 du. Yay! We know how to integrate this. Yeah, it is the magic behind the u sub. When we pick a part of the integrand to be u, make sure that we are able to rewrite the entire integrand in terms of u du, no x in there. the integral, the new integral must be in terms of u du, no x in there. Okay, let's take a look at a bunch of examples, see how we can identify the u. Which one should be the u? Number 2, how to pick u correctly. Example, which part of the integrand should be u? So if we look at the first one, right? Well, we see x squared minus 1 is inside the square root, and the derivative of x squared minus 1 is 2x. So that derivative is going to replace the 2x dx, which tells us that u is the part that is inside the square root. So here, u is x squared minus 1. du is 2x dx. Then this would become integral root u du. Yay! In B, integral e to the negative 0.01x dx. Well, very similar to what we did before. U is the exponent of e, negative 0.01x. du is negative 0.01 dx. So that means we divide by both sides by negative 0.01. dx is 1 divided by this, that's negative 100 du. So this is eu multiplied to negative 100 du. Yay, we can integrate this one. In C, notice that ln(x) is 1 over x. So I mean u is ln(x), du is 1 over x dx. And now we can do the substitution in here. This would be integral ln(x) is u, 1 over x dx is du. Ah, very cool. Next one, in D. Well, if we pick the denominator to be u, then the derivative of the denominator will help us to replace the x plus 1 dx. So we let u to be 2x squared plus 4x minus 1. du is 4x plus 4 dx. Or you can see this as 4x plus 1 dx. And so 1 over 4 du is x plus 1 dx, which means that we can rewrite this integral as 1 over u times x plus 1 dx is 1/4 du. Very cool. In E, notice that the derivative of sine x is cosine x. So that gives us the u. And another way that you can see this is, well, this is something over 1 plus sine squared. So it does look like the integrand is going to be written in terms of arctangent. And the derivative of arctangent is 1 over x squared. So here we let u to be sine x, and du is cosine x dx. this become integral of 1 over 1 plus u square multiply to cosine x dx is du. Yay, and the integral of this is the arctangent. Well, for the next example, it does look very similar. We just multiply sine x into cosine x over 1 plus sine square x. In this case, we have to somehow get rid of the numerator. Then notice that the derivative of sine square x is 2 sine x cosine x. So it does the job for us. So there's u equal to the denominator 1 plus sine square x. du here is 2 sine x cosine x dx. So that means sine x cosine x dx is half of du. And well, what we have here is the integral of 1 over u multiplied to 1 over 2 du. For the last one, once we do this thing here, the exponent of e should be the u. We'll let u to be root x. du is 1 over 2 root x dx. Well, 2 du is 1 over root x dx. And now with the u sub, we say that this is e u multiplied to 2 du. Amazing. Thank you for watching. I hope you found the content useful. I'll see you in the next video.